in the course you can see. Okay. Performance and the performance of an integrated IC. So how CMOS? Then you can see design the physical layout and the physical design of an IC. For that, you need to know how to design using CMOS. This custom logic circuits. Although it is using FPGA, but at first you have to know what is full custom logic circuit. For that you need what for this circuit. So this is the heart, or this is the main concept of this course. Okay, clear what I'm going to do? That is the main concept of this course. Let me go to first.
Sir, I'm recording only the lecture.
Okay, very good. So do you know what are logic gates, right? You all know what are logic gates, right? Abdul Qadir, Muraz, Saidul, Shuaib, Ibrahim, whoever at
yes, sir.
you know what is logic gates, right? Do you know what are logic gates?
Yes, sir.
Okay.
Yes, sir.
How many types of logic gates are there? There are 3 types of logic gates. One is basic gates, and or not, right? There is 3 types of logic gates. One is NAND, another one is NOR, right? Another type of logic gates are exclusive gates, right? Exclusive OR, that is XOR, or exclusive NOR or XNOR, right? You know, you already know. Do you know how the logic gates are created? How the logic gates are created? Can anyone have any idea how logic gates are created, are made? By using what? Okay, let me show you something. Logic gates. ICs, right? When you make any circuit or when you design any circuit, you have to deal with, that is when you breadboard or on circuit board, right? You have to deal with this sort of ICs, right? These ICs. Okay, you know, you are familiar with this, right?
Yes, sir.
You are familiar with this. Okay, fine. So you have to deal with this. And what are these? There are actually multiple logic gates in one IC. You can see here. You can see you have NAND gates here. In one IC, you have 4 NAND gates. What about this one? You can see this is AND gate, this is OR gate, this is this is how many? 13 input NAND gate. This is 6 X, that is 6. You have 6 NOT gate in one IC. But what are the things that are inside these ICs? Think about these NAND, okay? Or think about this NOT. This 14-pin IC has NOT gate inside. But what about the one single NOT gate? What about how many? What are the things you have inside one NOT gate? Have you ever wondered? Have you ever that? Let me see. NOT logic gate. Okay. This is a NOT logic gate. One, you will get 0. If you give 0, you will get 1, right? You know this, right? Everyone? Okay, let me check.
Yes, sir.
Let me check. This is an input. This is a NOT gate, and this is an output, right? I'm going to connect it using cable. This is the circuit. Now, if I run, you can see if I give 0, 0 means what? Here there is no color. That means it is 0, and the output is 1. If I give 1, the output. Can you see that? It is opposite, right? If I give 1, it gives you 0. If I give 0, it will So how this thing works, or why this thing work like that? What's inside logic gates? So far you have understood. So far you have studied from general electronics course and some other courses. You have studied gates, right? Not gate does that. AND gate does that. OR gate does that, right? You already know. Do you know why they does that, or not why they do that? Because A is a plural form, you know. Why they do that, you know? So today we are going to see why they do that and why they are made of. Okay, what they are made of. We will see that. Okay, at first we will talk about not yet. Okay, we will give 1, we will get 0, we will give 0, we will get 1, but we will see the internal structure of not yet. Okay, let me clear this thing up. Okay, the heart of the NOT gate have 2 transistors, because we all know our ICs are made of transistors, right? You already know that our ICs are made of what?
Logic gate, sir.
Yeah, what?
Logic gate, sir.
জাহিদুল বলো তো আমাদের আইসি, ওকে, জাহিদুল বলো তো যে আমাদের আইসি কিটা তৈরি হয়? যে কোনো আইসি, what about that? How ICs are created, how ICs are made? বলো তো। জাহিদুল
জি স্যার,
বলো আইসি কিভাবে তৈরি হয়? আইসি কি দিয়ে তৈরি হয়?
অনেকগুলো গেট ব্যবহার করেছে।
না, এটা আমি ফার্স্ট ক্লাসে বলছি। Transistors, ICs are created by using transistors. Okay, transistors. So our NOT gate, AND gate, OR gate, they will also be made using transistors. So আমরা এখন যেটা করব, we will use transistors to make NOT gate. Okay, what are the transistors? MOSFET, GAT, right? IGBT, all those things are transistors. But here we will use MOSFET, MOSFET, MOSFET. What is MOSFET? Metal oxide semiconductor field effect transistor, right? You know what is MOSFET. So we will use MOSFET here. Here you can see you have 2 MOSFETs. One is N-type MOSFET, another one is P-type MOSFET. So I'm going to use MOSFET first. I'm going to zoom it a bit. So I'm going to use a P-type MOSFET first. I'm going to use an NMOS. Okay, NMOSFET. On the top of the PMOS, I'm going to give a VDD, that is the 5 volt. On the NMOS, I'm going to give a ground, that is 0 volt. Okay, fine. Now next, I will be using what? An output to see the output. I'm going to give one input to see give the input actually. Now, this is the structure of your. You don't have to worry about this thing. What is this? You do not have to worry. No need to worry. Right now, we do not need to worry about this. We will study this thing so hard later. That's why you do not need to worry. Okay. I'm going to do what? I'm going to, okay, at first I'm going to remove this so that I do not have to see this. Okay. Now then I'm going to connect this. I'm going to connect this and this. Connect this. Now, which one is gate, which one is drain, which one is source? We do not know yet. Let me show the pin name. Yeah, pin name. Yes. Now look at this. If I zoom, no, zoom doesn't work because the writing doesn't become bigger. Here you can see this is the source. This is the PMOS, right? This is the NMOS. So this is the source, the upper one source, the bottom one is the drain. At the bottom, you have the NMOS. The upper one is the drain, the bottom one is the source. Remember, PMOS and NMOS, they will work oppositely. So NMOS, the drain is at the top, source is at the bottom. For PMOS, drain is at the bottom, source is at the top. Okay, and the other one is the gate. It's the gate, it's the gate. Understood, everyone? Hello, you understood?
Yes, sir.
Yes, sir.
Remember, the source are always your power. That is, your power is always connected to the source. The upper is giving you 5 volt. The bottom source is giving you the ground. So that is power, right? Ground and 5 volt. This together they become power, right? The power pins. So the power pin is connected to the source. The power pin is connected to the ground. Now, gate will be your inputs. So all the gate will be connected together and become your input, and drain will be your output. Drain connected together becoming your output. Gate connected together become your what? Become your input. Got my point, everyone? Hello?
Yes, sir.
Okay. Now we are going to simulate this. We are going to see how this thing works. I'm going to run it. Oh, one more thing. Remember this thing throughout your course, throughout your life. For NMOS, in the gate, if you give 1, that is 5 volt, okay, it will be on. On means conducting. Got my point? On means what? On means conducting. It will be conducting. That means if you give 1, this will be conducting. That means on. If you give 0, that means if you give 0 here, what will happen? It will be not conducting. That means off. Understood?
Yes,
This one
sir.
is for NMOS. PMOS will be opposite. If you give 1, it will be what? Off. If you give 0, it will be what? On. That is, if you give 1, it will be not on. If you give 0, it will be what? On. On means conducting. Got my point? Now let's check. Remember this. On means off for PMOS. On means on. 1 means on. Got my point? In NMOS. Okay? Remember this. So let's see this in the simulation. So if I give 0, 0 means what? Here I have given 0, right? So this 0 will go to the gate of this. This 0 will also go to the gate of this. For 0, NMOS, PMOS is what? On or off? For 0, PMOS is on or off?
On, sir. On.
On. So that's why it is connected. For 0, NMOS is off or on?
Off.
Off, sir.
Off. That's why it is open. Can you see that? It is open. It is open. So you have an LED inside you in your output. What happens here? You can see from this what is this VCC or the VDD, whatever you say, a 5 volt is coming, a current is coming, it is going through the MOSFET, then it is going through the what? Through LED, and then it is going to the ground. Because this circuit has 2 ground. Can anyone see this? This circuit has 2 ground. One ground is here, another here, right? So 5 volt, if a current comes, it will always go to the ground, because current always come from the voltage and go to the ground, right? So the current will come from here. Now it cannot go in this way, can it? It can't. It cannot. Why? Because it is open. Since the circuit is open, so current cannot go in this way. It cannot. No, not possible. So this ground, the current cannot go to this ground. Okay. So where it will go now? It will go this way, then it will go to the LED, then it will go to the ground. By doing so, the LED will be on. Got my point?
Yes, sir.
So you have 1. So if you give 0, your output is 1 because LED is on, right? What does the say? You got it?
Yes, sir.
Okay. Now give the opposite one. Let's give the opposite. So I'm going to click this, and you see I have given 1 here. Since I have given 1, this one will go to the gate here. This one will go to here as well. Then what will happen? This one will make the PMOS off. Can you see that? It is off.
Yes, sir.
And this will be on. Okay. Now here, think about this. Now your 5 volt is giving you a current, but this current cannot go down. Can it go down? Because your path is open, right? Your path is off. So can it go down?
No, sir.
No, sir.
It cannot go down. So there is no current in the circuit. But you can see your LED has 2 pins. One pin is the positive, another pin is the negative. Negative pin is grounded. Positive pin is also grounded. Can you see that? Right? Both of the pins, that is in your LED. This is your LED. This was supposed to be your ground. This was supposed to be your voltage, so that the LED will be on. But if you give ground here as well, will this LED on?
No, sir.
That's why it is 0. Got my point? So you have given what? You have given 1 in your input, and what you are getting? 0, right? So what is your truth table? Let's say this is your A, that is your input, and this is your Y, that is your output. So A and Y, what is your truth table? If you give 0, what is your output?
1,
1. If you give 1, what is your output?
0.
0. So that is your truth table. Understood, everyone?
Yes, sir.
Yes, sir.
So did you learn anything new? Did you learn anything new here?
No, sir.
You know everything from the previous courses? You know this thing from your previous courses?
Sir, electronics too, sir.
You have learned this thing in your electronics too?
Yes, sir.
That is the MOSFET design as well?
Only LED, sir.
Only LED, you know about from LED, but what about the CMOS design? This is called CMOS. Why this is called CMOS? Can anyone explain why this is called CMOS design? CMOS means what? CMOS means complementary metal oxide semiconductor, right? When you have one PMOS and one NMOS paired together, when one NMOS and one PMOS paired together, they form what? It's one NMOS plus one PMOS, that means a PMOS. When they pair together, they become what? A CMOS. One NMOS, one PMOS become one CMOS. Complementary. Complementary. What do you mean by this word? Complementary. Complementary শব্দটা মানে হচ্ছে বিপরীত, but জোড়া. বিপরীত বা জোড়া. They are not similar. NMOS and PMOS, they are not same, but they are opposite, but they become a pair. Like bat and ball, right? Bat and ball. Bat is opposite, ball is opposite, but without one another, they are useless, right? Got my point? Like pen and paper. Pen and paper. Pen is different, paper different, but without one another, they are what? They are useless. Got my point? So they become complementary. Complementary. Complementary means opposite but together. So that is called complementary. That's why it is called complementary MOSFET. And this sort of design is called Cmos design. Cmos. Okay, let me show you the whiteboard here. Remember, an NMOS, a NOT gate design is like this. You have to give a double line. Remember, give double line. These two are gate and gate, drain and drain. This one is gate. The upper one is source. Here you have to give the VDD. Remember, this sign is the VDD. You have to give this sign. And this sign is the ground. Okay, remember. Okay, the ground sign and the VDD sign is most important. Remember, if you forget, I will give 0. And from here, your output is there. This is your input. This is your output. So if it is A, this will be your Y. Got my point, everyone? This is a NOT gate. Got it? This is your NOT gate. You have one input, but you have one output. Okay. So this is the NOT gate. So let's go and see the other gates. Now we are going to see the what? Delete this. We're going to see the NAND gate now. NAND gate. NAND gate. Not AND, not OR. We will see the NAND gate first. Because one CMOS is a NOT gate. One CMOS itself is a NOT gate. NOT gate. NOT gate means a bar. The output is a bar, right? So whatever you are going to design using CMOS, it will have a bar. Whatever you are going to design, remember, listen to me very carefully. Whatever you are going to design using CMOS, it will have a bar on its output expression. It will have a bar. Whatever you are going to design, whatever. Later you can remove the bar. তুমি পরে ওই বারটাকে সরাই ফেলতে পারবা, but whatever you are going to design at first using CMOS, it will be a bar. So that's why we are not going to do the AND gate first. Rather, we will do the NAND gate first. Why? Because AND is AB, right? Y is equal to AB, the multiplication, and the NAND gate is AB bar. So whatever you are going to do, they will have a bar on top of it. So that's why we will do the NAND gate first, then we will go for the AND gate. Understood, everyone? So at first we have to copy this. Remember, for one input you have one NMOS, one PMOS. Now for two input AB bar, NAND gate, right? AB bar, two inputs, you will have two PMOS and two NMOS. Whatever the number of inputs are, you use equal amount of what? Equal amount of AND gate and equal amount of NMOS and PMOS. So I'm going to copy this. I'm going to copy this. Fine. Okay. This is your A. Let's say this is your A. And let's say this is your B. Now let's draw the think about this one. This one is for A. This one is for A. This one is for B. This one is for B. You can do the swapping. This one can be for B. This one can be for A. This one can be for B. This one can be for A. No problem. Okay. So I'm going to do this. I'm going to connect these to our A because I'm thinking this is our A. This is also our A. See, the gate and gate are connected for one pair of NMOS and PMOS. That means this is one CMOS. This part is one CMOS because one pair, one PMOS and one NMOS. Their gates are connected, okay? Because their inputs is same. Inputs are same. Now for next one, I'm going to connect this here. That's it. Now, so our inputs are connected together. This is one CMOS. From where we will take our output. Remember this, we will take our output from the middle of our PMOS side and our NMOS side. So at the middle, from the middle of our, from here. Take our output from the middle of our PMOS and NMOS segment. What is our PMOS and NMOS segment? Which one is our PMOS and NMOS segment? At the middle, this part, right? Right, everyone? This is the middle of our PMOS side and the NMOS side. From here, we will take our output. Yeah. Done. Now let's check. Oh, by the way, this is our Y. Just call it Y. Double click and click. Now let's draw the truth table and find the truth table here. How to find out the truth table? Let's make a table. Like this. First of all, let's say this is our A. I'm going to use a different color. Let's say this is our A, this is our B, and this is our Y. Okay. Now here, what are the combination you can have? You can have 4 combinations: 0, 0, 0, 1, 1, 0, and 1, 1. Let's find out this combination and see the output. Okay. For 0, 0, if I click run, you can see 0, 0. For 0, 0, what is happening? What is happening for 0, 0? This is 0, right? And this is also 0. So this 0 is going here. This 0 is also coming here. This 0 is going there. This 0 is coming here. Understood, everyone?
Yes, sir.
Understood? Okay. Now for 0, your PMOS is on or off?
On.
On. Very good. This is on. This is also on, right? For
Yes,
0,
sir.
NMOS is off or on?
Off.
That's why it is off. This is off. So what is happening here? What is happening here? The 5 volt, the current from there is coming in this way and is also coming from this way, right? And then they are together here, but they cannot go down. They cannot go to this ground, right? Can come and go to this ground? No, it cannot, because
No.
the path is open, right? Here it is open, here it is open.
Yes,
So
sir.
the current cannot come down. So where it will go? Both of them will go and go to the ground, right? Everyone?
Yes, sir.
Understood? Okay. Now you will have 1. That means for 0, 0, you have 1. Okay. Now for the next one, for 0, 1. Now what is happening? Now what is happening for 0, 1? Like 1 here. This is the 0, this is going there, this is 0. This is also 0, it is coming here. Here you have 1. Here you have 1, right? You can see by using the color of the gate, there is a color, right? Red means 1, blue means 0. Now what is happening? What is happening here? For 0, the PMOS is on, but this for 1, this is what? This is off. For this NMOS is off. For this one, the PMOS, the NMOS is what? On, right? So one PMOS is on, one PMOS is off, one NMOS is off, one NMOS is on. Now, do you know what will happen? It will come in this way. Now the current cannot go in this way, right? Can it? No, the current
Yes,
cannot
sir.
go in this way. Can it go? No, it
No,
cannot
sir.
go in this way. So where the current will go? Current will go through this path. It cannot go down. Can it? It cannot go in this way. Can it go?
No, sir.
Now what will
No,
happen
sir.
now? It will go through the LED and go to the ground. So what you will get? For 0, 1, you are getting what? You are getting 1. Got my point?
Yes, sir.
Similar thing will happen. Similar thing will happen if you use 1, 0. If I give 1 here and if I give 0 here, this is 1. This should be 1. I didn't change it. I will change it. No problem. This will be 0. This will be 0. So let's change it. As you can see, for 1, PMOS is off. But for NMOS is what? NMOS is on. For 0, this one, PMOS is on. What about the NMOS? NMOS is off, right? Got my point?
Yes, sir.
Okay. Now what will happen? The current will come. It cannot go in this way. Can it go? No.
No.
So it will go what? In this way. Then what will happen? Then what will happen? Can the current go in this way and go to the ground?
No, sir.
No. Because the one path is open. So where the current will go? The current will definitely go from here and go to the LED. So you will get 1. Now for last case, that is the 0, 0. Now for 1, 1 actually, not 0, 0. For 1, 1, what will happen? This is 1, this is 1. So this is 1, 1, 1, 1. So for 1, 1, what is happening?
Zero.
What is happening here? You can see this PMOS is off. This PMOS is off. This NMOS is on. This NMOS is on. So current can come in this way. No current can come in this way because both of the roads are open, right? So your LED will not be on because there is no current. Rather, it will have ground in its this pin as well, right? It has a ground, so it has a discharging path. Okay, it's a short part to the ground, so it will discharge. Got my point, everyone?
Yes,
Yes,
sir.
we get, sir.
Okay, so your output will be 0. This is what? This is NAND gate, right? This is NAND gate. So 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1 is 0. So your output equation becomes AB bar. So Y is equal to AB bar. Okay, everyone?
Yes, sir.
Yes, sir.
Okay. Take 5 minutes off as a break and find out what is AND gate. Show me the design of AND gate. Okay. Okay, everyone.
Okay, sir.
AND gate, AND gate. Think about this and find a solution how to design the AND gate.
Sir, it's opposite of this.
Yeah, not fully opposite, but they are similar. Remember the first design I have shown you and the second design? You will get your idea from here. Try to find out. Now it is 11:16. I will be back at 11:21. Right? That do not have any power, just AB, right?
Yes, sir.
Okay. Do you know how to do that? Got any idea? Anyone?
স্যার ওই যে উপরে যে পি বার পি মাস আছে ওই দুটা মাস দিলে আর যে নিচে দুটা
No. This is a very bad idea. Never. Your PMOS will stay at the top. Your NMOS will stay at the bottom forever. VDD will be at the top. Your ground will be at the bottom forever. You cannot change that. I mean, তুমি কেন চিন্তা করছো? Since they are opposite, so we will make them opposite. Right? No, do not do that. There is one more smart solution to this. Not smart actually. This is the only solution. What is the solution? Do you know? If you make a NOT gate, it become what? A bar, right?
Yes,
Yes,
sir.
sir.
If you make it again, what will be the result? A double bar, right? One NOT gate gives you one bar. Two NOT gate, it will give you six, right? Finally, what
Yes,
happens?
sir.
Do you know bar cancel each other? Do you know why? Because one becomes zero. That means zero becomes zero. They are same, right? So NOT gate can gives you bar, and NOT gate can gives you ability to remove one bar. Got my point? Somalian students, are you hearing me?
Yes, sir.
Okay. NOT gate can give bar, and it can also give you the ability to remove one bar if you want to use it. Let's see this. So if I'm going to remove, okay, I need some space. Now think about this. This is an AND gate. Think about this. This is an AND gate. Then you connect one NOT gate together with it. That means with your AND gate output will go to the input of the NOT. So what will happen? A, and if you give B, what happens? Do you know? This become what? This become AB. What will happen here? Can anyone explain? This become AB bar. Okay, everyone?
Yes, sir.
You understood?
Yes, sir.
This thing you know from your digital electronics course. Now let's try again. I'm going to do this time. Uh-oh. Here, what we're going to do? We're going to do this. If we have a NAND gate, here it is your A, here this is your B. Your output is what? AB bar, right? Now, what if
Yes, sir.
we connect a gate with the output of the NAND gate? What will happen?
AB.
This will be A B double bar. Your AB. AB double bar means what?
AB, sir.
This is AB. So that is what exactly we are going to do. We are going to connect a NOT gate here. Remember the previous line that we have done? Okay, let me switch it off. Remember the previous line that we have done? What was the previous design? Can anyone explain? One PMOS, another one,
Cmos, sir.
and another NMOS, right? Remember? That means one CMOS actually, one CMOS. I'm going to connect it here. Fine. Now, and the gate will be connected to it. Now, what is this? This little part, what is this? This is the NOT gate, right? Here you have your input of your NOT gate. Here you have your output to the NOT gate. Can anyone see this? Do you remember?
Yes, sir.
Do you
Yes,
remember
sir.
the previous circuit? This is the NOT gate. So what we are going to do? We are going to connect. We are going to connect the output of NAND gate with the input of NOT gate. That is here. Output of NAND gate with the input of NOT gate. Then we are going to connect the output of NOT gate with the output LED. So we're going to do that. Then you will see how this thing works. We're going to connect it here. Now this is our AND gate. See, for 0 0 it is 0. For 0 1 it is 0. For 1 0 it is 0. For 1 1 it becomes 1, right? For 0 0 it becomes 0. For 0 1 it becomes 0. For 1 0 it becomes 0. For 1 1 it becomes what? 1, right? So that is your truth table of what? Of AND gate. So what is the equation? What is the expression? Not equation, I should say expression. What is the logic expression? Y is equal to AB. Okay.
Yes, sir.
So when we will have our next class, not Wednesday, because Wednesday, not Thursday. Thursday is our regular class. But since we have missed a lot of classes, right?
Yes, sir.
Not you, of the logic gates using CMOS, and make a report of like this. What is that? The truth table and logic expression. Okay, everyone. If you use computer, it will be better. Remember, I told you in the previous semester, you have to manage one computer for this course. I'm not saying you have to buy one, you have to manage one. Got my point?
Hello, sir.
Hello.
Sir, can you make again an assignment, sir?
Okay. Design all 7 gates. NOT gate, AND gate, NAND gate, OR gate, NOR gate, XOR gate, XNOR gate. All 7 gates using CMOS and write their logic expression and the truth table. Okay?
Yes, sir.
Submit when? Submit on Tuesday. Okay? Submit on Tuesday. বুঝতে পারছি?
Yes, sir.
মঙ্গলবার, Tuesday. Tuesday when? Let's say 12 o'clock, 12 p.m. Not at night, in the afternoon.
Okay.
Okay. So 12 p.m. you have to submit all of those in a PDF, obviously. If it is like this, the screenshot of this, like this, it will be better. It will be what? It will be better. So Bangali kara আছে এখানে? Sakline